node method. Node method is a basic toolkit for circuit analysis. Okay. For circuit analysis, you can analyze all circuits on the earth and in the space. Okay, it always works. Sometimes you can analyze the circuit intuitively, very easily, but sometimes the circuit can be complicated. Okay, if you don't know how to analyze that circuit, the answer is node method. Okay, if you cannot imagine the easy solution, you can use node method and it can analyze all circuits. It's actually application of KCL and Ohm's law. Okay, but the short application. You can analyze a circuit using lots of KCL equations, KVL equations, lots of information using, but node method shows you how to apply the KCL shortly to analyze a circuit. It has 5 steps. First step is select a ground. Okay, there are some nodes in the circuit. If it is not given to you, the ground is not given to you, you have to select a ground. Second step, name the nodes. Name unknown nodes. If the voltages of nodes are obvious, write the voltages. But if they are not obvious, okay, if you don't know the values of the node voltages, give some names. Okay, E1, E2, node 1, node 2, VA, VB, anything. The third step, write KCL equations on unknown nodes. Okay, only you will write the KCL equations for unknown nodes, not all nodes, but only on unknown nodes. It's enough. Then rewrite KCL equations using node voltages. Okay, KCL equations are currents. Step 4 says write those currents in the form of node voltages. Okay, and then most of the time number of equations will be equal to number of unknowns. It means you can solve the set of equation. Solve the set of equation for node voltages. Okay, so if you know the node voltages of the circuit, you can calculate all values of the circuits. Let's apply on a sample circuit. That's resource. Let me say Vx. Vy, R1, R2, R3. Assume I know the values of sources, I know the values of resistors, And question, what's the voltage of this point with respect to this point, for example? Okay? Or you can find any voltage of any component, voltage of any current of any component. Okay, you can find everything. You can find the powers of the components. Let's calculate the power generated by the current source, Pi. Okay, that's the power generated by current source. Question. So I need to find the current is given. I know the current value, but I have to find the voltage of that component. So let me use the node method and calculate the voltage of that component, and then find the power dissipated by that component. Step 1. Let me copy the steps. Okay. Step 1. Select the ground. Many times the negative side of voltage source is a very proper point for a ground. Okay, it makes your calculations easy. So I select this point, and this point are the same points. Okay. Step 1 is okay. Name unknown nodes. Give some names if the value of voltage of that node is not known. If you don't know that value. What's the value of this node? What's the voltage? What's the voltage of ground? 0. Okay. Ground is an assumption. You assume it's 0 volts. There is a voltage source. Its value is Vx. Voltage source always maintains a fixed voltage between 2 points. So if this point is 0, what's the value of this point? Vx. Okay. It's the job of voltage source. Always the difference between 2 points should be Vx. Then, what's the voltage of this point? I don't know. Let me give some name. I say Va. Okay. What's the voltage of this point? I can say anything. Okay, Vb, Vc, but as you see, this voltage is defined in the question. It says the difference between these 2 points is Vy. Negative side is 0. So what will be the positive side? Vy. Okay, Vy. Or you can say, let this be Vb. Okay, because I don't know Vy, I don't know Vb. Okay, so how many unknowns are there? 2. Va and Vb. I have named the nodes. Step 3. Write KCL equations on unknown nodes. There are 2 unknown nodes. I will write 2 equations. Let's write. Okay. But I have to define some currents to write KCL equations. I have to define some voltages and some currents. Let me define some voltages and currents. V1 and I1. V2, I2, V3, I3. What's that current? This is I2. What's that current? I2. The same current. Okay. What is this current? Let me write the value. The value will be IY. I know that value. So what is this value? It's the current of current source. IY. I know that value. I don't know the voltage of the current source, but I know the current value. So let's apply KCL on VA. Let me copy my circuit and look at it while writing the KCL. Okay, which currents are entering to VA? I1, that's it. Exitings, I2 plus I3. Then, that's it. KCL on VB, which is entering I2, which is exiting, sorry, there are two currents entering. Exitings, 0. Okay, so from here what can I say? I2 is IY, so I know the value of I2. Minus IY. Minus IY. Okay, I know the value. So I don't know two of the currents, I1 and I3. In question, in step, I have completed step 3. In step 4, it says, rewrite the KCL equations using node voltages. But you will write if you don't know the value of that current. So let's rewrite this equation. Okay, I will rewrite this equation. I1. Can you say me what's I1 in terms of node voltages? I1. What I mean is this. Look, if you have a resistor, it has a voltage. It has a current. IR, VR. Node voltages are something like that. E1, E2. Okay. In this resistor, VR is equal to, okay, VR is the voltage of that component, is equal to positive side minus negative side. E1 minus E2. And the current of that component is VR divided by R. So VR is equal to E1 minus E2 divided by R. Okay. Write the current in terms of node voltages. Means this. Okay. So what's I1? Look at here. Positive side Vx. Negative side VA. Resistance R1. Okay, that's it. What's I2? I2 is known. I know the value of I2 minus IY. No need to write voltages divided by resistance. What's I3? Positive side. Look, positive side is VA. Minus negative side, which is ground, divided by resistance. Okay, so I will rewrite this equation. Okay, this equation, but I will use this I1, this I2, and this I3. Okay, so let's rewrite. I1 is equal to, this is I1, okay, I1 here is equal to what? I2 plus I3. What's I2? Let me copy I2. I2 plus I3. Okay. So I have only one equation. I have only one unknown. What's the unknown here? Solve this equation for VA. In this equation, I don't know only VA. So I can easily find VA. Okay? So, after finding VA, I know the current of this resistor. Can I find VB? Let me copy that circuit and try to find VB. I have calculated VA. That's it. What's VB? VA is equal to VB plus V2. How can I write this? Voltage of VB is here. Voltage of VA is here. What is the difference between VA and VB? V2. Okay. Look at here. VA minus VB is equal to V2. So what's VB? I can write this. V2 is VA minus VB. So VB is VA minus V2. Okay. I have calculated VA. What's V2? V2 is I2 times R2. So VB is equal to VA minus I2 times R2. What's VY? I have calculated VB. What's VY? It's equal to VB. Okay? And what's the power generated by that component? Power generated at current source, I source. It's equal to voltage times the current. But that current should be entering from minus. Generated current means, generated power means the current is entering from minus. It's the definition. If you use the current entering from positive, it will be dissipated current, dissipated power. But this is generated power. So, what's the voltage of that component? Vy times. What's the current entering from negative? It's given Iy. Okay, this much of watts. That's it. No, it's already, look, it's already entering from the minus. That value is already in the desired form.